Hi everyone, this is Dr. G. Ravindranath Reddy, Assistant Professor in MLR Institute of Technology. So here the course is Numerical Methods and Integral Transforms. In this course we are going to discuss numerical techniques. So in this video, first we will give some introduction of numerical techniques, when we have to apply these numerical techniques. What are the numerical techniques we are having for the different concepts, and then we will go for the bijection method and with examples. So here once if you go through this overview of these numerical techniques, so in our syllabus we are going to discuss root finding techniques, and the next one is numerical integration and the numerical solution of ordinary differential equations. In this root finding techniques, we are having bijection method, Regular-Falsy method, iteration method, and Newton-Raphson method. So these are the four methods we are having to find out the root of an equation here. And when you come to this numerical integration, under this numerical integration, we are going to discuss trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule. So these are the three standard rules we are going to discuss under numerical integration. And the last concept is numerical solution of ordinary differential equations. So in this we are going to discuss Taylor series method, Euler's method, modified Euler's method, and Runge-Kutta method. By using these methods, we are going to find out the numerical solution for the given ordinary differential equations here. So this, once if you complete these all methods in all three concepts, then we can complete our numerical techniques here. So now we will start with root finding techniques. So these are the methods we are having. So before going to discuss about these root finding techniques, we will see why we should use, why we have to go to the numerical methods or numerical techniques. So when we have to go to these methods, we will discuss one by one. So first we will go for this equation, this introduction of this root finding techniques here. So first I will take one equation. So this is x cube plus x square plus 2 is equal to 0. So this is an equation I have taken, and in our lower classes we have seen how to find out the roots of this equation by using this synthetic division. And similarly, suppose if we have a quadratic equation x square plus 2x plus 3, then for this also we have the standard procedure, standard formula to find out the square root for the given quadratic equation here. So here we don't have any problem with this type of equations, polynomial equations, but in this polynomial equation some functions are involved. Suppose if we take x square plus sin x is equal to 0, then this is the equation we got, x square plus sin x is equal to 0, and for this we have to find out the roots of this equation here. So for this we are having some standard procedures like a synthetic division or like a factorization method or something. We have the standard procedures to find out this type of polynomial equations. But in this equation, suppose if any term contains some functions like trigonometric functions, like exponential functions, logarithmic functions, if these functions are involved in that equations, then these methods will not be useful here. So in this case, then we have to go to the methods of numerical methods. We have to jump into the numerical techniques here. So this is the main advantage of this numerical methods, root finding techniques here. So once again I will repeat this. So whenever we are having these type polynomial equations or an algebraic equations, for these equations we can apply whatever we have studied in our lower classes like factorization method or synthetic division. Like this we can, by using that methods we can find out the solution for this type of equations. Suppose in that equation, suppose if any function is involved like trigonometric function, like exponential function, like logarithmic functions, or inverse trigonometric functions like tan inverse x, Whenever these functions are involved in this type of equations, then these equations it is not possible to solve by using our standard methods which was learned in our lower classes here. So in order to get the solution for this type of equations, these equations we can call it as a transcendental equations. For this type of transcendental equations, if you want to find out the roots, then we have to go to the concept of numerical techniques. That is the main use of this numerical techniques here. So now in this numerical techniques, first we will go for the bisection method. This is our first method in the root finding techniques. Now one by one we will discuss the procedure how to use this, how to apply this bisection method. So this bisection method also we can call it as a simple iterative method or simple iteration method, and this is also we can call it as a Bolzano's method of successive approximations, or sometimes we can call it as a half interval method. So like this we are having different names for this bisection method. So first of all, this bisection method is a iterative method. Now we will see what is meant by iteration. So iteration is nothing but repeating the same step number of times. Suppose I have taken one step here, we will follow the same procedure for number of times until we get our required value here. So repeating the same step for the number of times, these methods we can call it as a iterative methods or iteration methods. So this we have different names for this bisection method. One we can call it as a Bolzano's method of successive approximation or successive bisection, or we can take it as a half interval method. Now these are the different type names of this bisection. Now we will go for the procedure here. Now whatever the equation we have given, we have to compare that equation with this standard form. Is f of x is equal to 0. For example, I have taken a polynomial equation x square plus 2x plus 3 is equal to 0. So whatever the equation he has given, we have to convert that equation into standard form. Similarly, if you want, you can take x into e power x minus 2 is equal to 0. Suppose instead of this, if you have like this, so if you have x into e power x is equal to 2, then we have to convert this into this standard form like x into e power x minus 2 is equal to 0. This is our standard form of that equation here. So that standard form is compared with f of x is equal to 0. Now compare this and get the value of f of x. That is the first point we have to remember. That is the first step we have to do. And the second step is we have to choose two real numbers. If you substitute the two real numbers in this function f of x, if you substitute the two real numbers in this function value must have opposite signs. Suppose if you take x0 and x1, if you substitute that x0 in the function here, you will get f of x0. Suppose if you get this value as a negative value, and then if you substitute the next real number, that is x1, we have to get this value is a positive value. So like this, we have to choose two real numbers such that their function values must have opposite signs. So this indicates that whatever the root we are going for this equation f of x is equal to 0, that root lies between these two numbers. So whenever we are having a function value is with opposite signs, then we will consider that whatever the root we are going to find out, that root lies between these two real numbers. This indicates that. So now this is our interval x0 comma x1. Now we have to bisect this interval into two subintervals. So that is two half intervals. So that we can take as x2 is already x0 and x1 is completed. Now we are going to find out that x2 value here. That x2 value is given by the average of these two numbers, that is x0 plus x1 by 2. By using this formula, we will find out the value of x2. So after finding this x2 value, once again we will substitute this x2 value in the same function. You will get our f of x2 value. And you check whether this function has a positive value or negative value. Based on this positive and negative, we are going to discuss here. Suppose if that f of x naught, f of x2 value is equal to 0, then we can consider that x2 is the root of that equation. So by using this formula, whatever the value we got for x2, you substitute this x2 value in the function f of x. If that after substituting that x is equal to x2 in the function, if we get that value is equal to 0, then we can conclude that x2 is the, whatever the value we got this x2, that we can consider as the root of this equation. Suppose after substituting that x2 value in the function, if that x2 f of x2 value is not is equal to 0, then there is a scope to get this value as a negative value, or there is a scope to get this value as a positive value. So in that case, then what we have to do is, suppose if f of x1 and f of x2 have same sign, if f of x1 and f of x2 have same sign, then we can conclude that the root lies between x0 and x2. For both functions f of x1 and f of x2 have same sign, then we can neglect that x1 and we can, in place of x1, we can consider this x2 value here, and then we can conclude that that required root, whatever the root we are going to find out, that root lies between x0 and x2. Otherwise, if these two, f of x1 and f of x2 have opposite signs, then we can conclude that the root lies between x0 and, otherwise the root lies between x1 and x2 value. We can neglect that x0 and we can consider this x1 and x2 here. So like this, we have to follow the same procedure for number of times. After, suppose if you consider this is the interval we got after neglecting that x0. So our interval is x1 and x2. Already we have completed x2 value. Now we are going to find out x3. Now for this x3, find out the average of this x1 and x2. So you will get x1 plus x2 by 2. You will get x3 value. Once again you substitute this x3 value in the function. If that x3 value is equal to, f of x3 value is equal to 0, then we can conclude that x3 is the root. Otherwise, once again we have to follow this procedure here. Okay, I will explain this procedure neatly by taking one example here, so that by that example we can understand this procedure what we have discussed clearly. So now let us take this equation, find the root of the equation using bijection method, and you follow this up to 5 stages. Okay, so what is meant by 5 stages and all these things we will discuss now. Now this is our function. The equation x cube minus 5x plus 1 is equal to 0. This is a polynomial equation we got. Now for this polynomial equation, for this equation also we can apply the bijection method and we can find out the root. But here, since it is a cubic equation, you will get 3 roots. But here we are not going to get 3 roots here. So we are following this procedure just to find out the one root out of these 3 roots. Okay. So we are going to find out only one root here, not 3 roots. First we will see the procedure how to find out the root of one single root for the given equation here. So already we said that in the procedure we have to convert this equation in the standard form, f of x is equal to 0. Now you compare this f of x is equal to 0 with the given equation and get the value of f of x. So you will get our f of x value is equal to this. F of x is equal to x cube minus 5x plus 1. Now here, now we got the value of f of x is equal to this. Our next step is we have to find out the two real numbers. One is x0 and one is x1. So really, we don't know what are the two real numbers here. We have to get the two real numbers here. For this purpose, we will start with x is equal to 0. We will check whether this one by one. First we will take f of x is equal to 0 and we will get the value of x0, f of 0, and we will get the next number x is equal to 1. We will get the value of f of 1. So now if you take x is equal to 0 here and you substitute that x is equal to 0 in this function f of x, you will get 0 minus 0 plus 1. You will get that value is equal to f of 0 equal to 1. So 1 is a positive number, so this is a positive value here. Now you take next x is equal to 1 and you substitute that x is equal to 1 in the function f of x is equal to x cube minus 5x plus 1. So now you substitute x is equal to 1 here. You will get 1 cube, that is 1, minus 5 into 1, that is 5, plus 1. So 1 plus 1, 2, 2 minus 5, which is equal to minus 3. So we got f of 1 is equal to minus 3. So when we take x is equal to 0, we got f of 0 with a positive sign. When we take the next successive number, we got x is equal to 1. We got f of 1 is equal to with negative sign. So for x is equal to 0 and x is equal to 1, for x is equal to 0 and x is equal to 1, their function values having opposite signs. F of 0 is positive and f of 1 is a negative value here. So since because of this reason we are having opposite signs for f of 0 and f of 1, because of this reason we can conclude that f of 0 and f of 1 are having opposite signs, then we can conclude that the root lies between 0 and 1. So if you represent this root lie in the number line here, so you consider this as 0 and you consider this as 1. Whatever the root we are going for, this root lies between in this interval 0, 1. So like this we have to consider the two real numbers for the given equation here. So whatever the root we are going to find out, that root always lies between 0 and 1. Whatever the value we get, that value is in between 0 and 1. That is the second step here. The second step is we have to consider two real numbers, and if you substitute the two real numbers in the function, their function value must have a opposite signs. So suppose this is a positive sign, if you take the next number we have to get a negative sign. So since we are having opposite signs, so we can conclude that the root lies between 0 and 1. That is our second step here. Now I want to represent this 0 with x0 and I want to represent that second real number as x1. So x0 is equal to 0 and x1 is equal to 1. Now we are going to find out the next value x2 here. So now I want to apply that bijection method. Till now I am not applied this bijection method. Now I am going to find out this. I am going to apply this bijection method for the next approximation. That is next x2 value here. So this is the formula we have seen in the procedure. x2 is equal to x0 plus x1 by 2. So just now in the previous slide we have taken x0 is equal to 0 and x1 is equal to 1. So x0 0 x1, so 0 plus 1 1 by 2, we can get this value is equal to 0.5. So finally we got x2 is equal to 0.5. Okay, so now whenever we get this conclusion that whatever the root we are going to find out in between these two real numbers, suppose we have taken x0 is equal to 0 and x1 is equal to 1, and we got f of x0 value, that is f of 0. So we got f of 0 is equal to, f of 0 is a positive sign, this is a positive sign, and f of 1 or f of x1 we are having a negative sign. So now we are taking, we got this x2 value. So we have taken that x2 is equal to 0.5. You represent that x2 value here 0.5. Now after getting the new value for x2, now immediately what we have to do is we have to substitute this x2 value, that is 0.5, in the function. So f of x2, that is f of 0.5 is equal to, we got a negative sign here. So we got a negative value minus 1.375, which is less than 0. Now you represent this here, f of x2. So f of x2, we got f of x2 is a negative sign here. Now from this figure we can, if you observe this one clearly, we are having one positive sign and two negative signs here, but we want only one positive sign and only one negative sign. So now out of these two negative signs we have to neglect one negative sign. Now we will see which value we have to neglect here. So now this is a positive sign which is not repeated. Now go to this positive sign and from this you identify the nearest value. So so when we compare this 1 and 0.5, so this 0.5 is the nearest to this value because opposite this plus sign is not repeated, so this is unique. So for this unique sign, you identify the remaining two real numbers, that is 0.5 and x1 equal to 1. So out of these two, this 0.5 is the nearest value. So you keep this 0.5 as it is and you neglect this x1 is equal to 1. This is far away from this 0. So now we can conclude that whatever the root we are going to find out, that root lies between 0 and 0.5. After neglecting that x1 is equal to 1, finally we got the two real numbers, that is one is 0 and the next one is 0.5. So like this we have to decide and we have to neglect one real number here. Now from this I think we have understood this point. So you whatever the values x0, x1 and x2 we got, you replace that function values with a sign. So for f of x0 we got a positive sign, for f of x2 we got a negative sign, for f of x1 we got a negative sign. So one positive sign we got and the negative sign is repeated twice. So now you go to that positive sign, since it is a unique, it is not repeated. Now from this point you identify the number which is nearest to this point. So it is very clear that x2 is very near to compared to this x2. So we have to consider the nearest value and we have to neglect the remaining value. So neglect this 1 and you consider this 0.5 for the next step. So because of that reason we have concluded that whatever the root we are going to discuss, going to get, that root lies between 0 and 0.5. So next, after getting two real numbers, so now the same procedure we apply here. So you reprint this 0 and this is the next number is 0.5 and we got f of 0. F of 0 is positive sign and f of 0.5, that is x2, f of 0.5 we got a negative sign. Now here this is x0 and this is x2. Now we are going to find out x3 value here. Now take x3 is equal to average of these two numbers, we will get 0.25. You represent that x3 is equal to 0.25. Now immediately after getting that x3 value, you substitute that x3 value in the function. So f of x3. Now you check whether that f of x3 is a positive value or negative value here. So now f of x3. So we have the function f of x is equal to, we have taken that value x cube minus 5x plus 1. So this is our function x cube minus 5x plus 1. So in this you substitute x is equal to 0.25. So you will get 0.25 whole cube minus 5 into 0.25 plus 1. If you calculate this, you will get this value with a negative sign. So you represent that negative sign here. So now you observe this, only this figure. Observe this. So here we are having one positive sign and two negative signs. And here also the negative sign is repeated twice. So now out of that repeated sign, negative sign, we have to neglect one negative sign and we have to consider one negative sign here. So for this purpose, you go to the sign which is not repeated, that is a positive sign, x0. Now from this x0, follow the same procedure. You consider the value which is nearest to this 0. So for this 0, the nearest value is 0.5. The longest value is, this is at far away from this x0, that is 0. You neglect this and find out, consider this x3 value here. So since f of x0 and f of x3 are opposite signs, then we can conclude that the root lies between x0 and x3. That is the step here. And similarly, follow the same procedure. Now you take the next number. Now x3 is completed. Now you represent this here. This is x0 and this is x3. And now we got f of x0. F of x0 is a positive sign and f of x3 we are having a negative sign. Now we are going to find out the next approximation, that is x4. Now you calculate this, follow the same procedure. So the third approximation, so the root lies between, we have taken the statement as the root lies between x0 and x3. So take the average of this x0 and x3, you will get 0.125. So we got 0.125. This is our x4 value. Now immediately after finding this x4 value, you substitute that x4 in the function f of x4. This is our function. You replace x with 0.125 and get whether we got a positive sign or negative value. So now after substituting here in this function, we get f of x4 with a positive sign. You represent this positive sign here. Now once if you observe this figure clearly, so now in this plus is repeated twice and we are having only one negative sign. So now out of these two positive signs, we have to neglect one positive sign and we have to consider one positive sign here. So now for this purpose, you go to the value whose we are having a only unique sign, that is minus sign. So you are at this point x3. At this, from this x3, you identify the nearest value. So this is our nearest value then compared to this x0. So because of this reason, you cancel this x0 and you consider x4 with a positive sign and f of x3 with a negative sign. So now since f of x4 and f of x3 are of opposite signs, then we can conclude that whatever the root we are going to find out, that root lies between x3 and x4. Follow the same procedure, you will get our required value here. So our root lies between x3 and x4. So represent this x3 and x4. Now we got f of x3 and we got f of x4. Now f of x3 we are having a negative sign and f of x4 as a positive sign. So f of x3 we are having a negative sign, f of x4 we are having a positive sign. Now we are going to find out our new approximation, that is x5. So take the average. So our x3 and x4, these are the values. Take the average of this, you will get x5 is equal to 0.1875. Sorry, 0.1875. Now find out f of x5 and check whether you will get a positive value or negative value for f of x5. So now we got f of x5 is a positive value. F of x5 is a positive, so we print this positive sign here. Now once if you observe this, we are having two positive signs and one negative sign. Out of these two positive signs, we have to remove one positive sign which is far away from this negative sign. However, we got this negative value for x3. So for x3, the nearest value is this one. The far away, this x4 is far away from x3, so you neglect this x4 and you consider x3 and x5 for the next approximation. So that's why we have taken f of x5 and f of x3 are of opposite signs, then the root lies between x3 and x5. You represent this. This is x3 and this is x5. So f of x3 we are having negative sign and f of x5 we are having a positive sign. So now we are going for the next approximation, that is x6. Now this is our x6 value. So we got x6 is equal to 0.21875. Now no need to find out this f of x6 here, because in the problem he has mentioned only 5 stages. 5 stages means we have to find out up to x6. Suppose if you want to go for the next stage, then we have to find out this f of x6 value here. So in the problem he has mentioned that for only 5 stages. Suppose if you want to, suppose that 5 stages is not mentioned in the problem, then we have to repeat this same process. Suppose if you want to stop this at x6, then whatever the value we got for x6 and we will compare that x5 values. So minimum after decimal point, the minimum 3 digits must coincide here. So here after decimal point the digits are 187. Here we are having 218. So even the first digit is also not coincidence. So we have to repeat this process until we get the present approximation value must coincide with the previous approximation. Suppose if you got x12 and if you want to stop that problem at x12, then we have to compare that x12 value with x11 value. So then in this, after digit decimal point, minimum 3 digits must coincide here. Until if these 3 digits are coincidence with the present approximation with the previous approximation, then we can conclude and we can stop the problem and we can conclude that value as our required root here. Suppose in this case also these values are, these decimals are not coincidence, then we have to follow until we get a more accurate value. That means until we get the present approximation and previous approximation values must coincide. Okay, so since we are repeating, so once if you observe here, the same, taking the average of two numbers, here we have taken the average of these two numbers, we are repeating this process number of times. So repeating the same process number of times, then we can call this method as a iterative methods. So this bijection method is one of the iterative method to find out the root of the given equation. So this is about bijection method. So once if you represent that values here like in this like figures, then it is very clearly we can understand and we can decide which number we have to eliminate and which one we have to consider for the next approximation. So this is about this. So here we have taken, so in the problem they ask 5 stages, so we have completed up to 6th stage. So whatever the value we got in the 6th stage, we have taken that value. So now once if you want to check whether whatever the value we got, that value must be, at the beginning we have taken that root lies between 0 and 1. We can cross verify that whatever the value we get for this present approximation, that value must be in terms of 0 and 1. That is the verification of this root, whether that root we got the correct value or wrong. So this is about this bijection method. Now in this video we have discussed procedure for bijection method and we have explained that procedure with a single example. Now in the next video we will go for the next root finding technique, that is regular falsy method. So what is the procedure in the regular falsy method, what is the formula we have to use and how to get this. So here the important thing what we have to remember is this bijection method, we have some disadvantages with the bijection method here. So that is the disadvantages. So we have to, in order to get more accurate value in this bijection method, we have to apply this procedure number of times. So number of times we have to apply this in order to get more accurate value. That is our disadvantage of this bijection method here. So in the next video we will discuss about the regular falsy method. So somewhat we can overcome that drawback of this bijection method in the regular falsy method. Thank you.